All right, everybody. In this next video, I want to continue with adding and subtracting whole numbers, but I want to focus on applications here. So I'm going to title my notes for today, Applications with Adding and Subtracting whole numbers. And again, I do encourage you to put the date on here as well, or at least within which unit or week that you're working on. So one application, one of the biggest applications we have, particularly with addition, is the idea of perimeter. So the perimeter of a polygon, now a polygon could be a triangle, a square, a rectangle, etc. So any sort of sided closed object, right? Triangle, square, rectangle, octagon, pentagon, anything like that. And it is the distance from a polygon is the distance around the polygon. So basically what you do for perimeter is you add up all sides. So for example, let's say I had a rectangle and these sides were both 2 and these sides were both 6. Then the perimeter of my rectangle in this case is going to be 2 plus 6 plus 2 plus 6. So I'm adding up all my sides here. So I end up getting 16. Now we'd also have units here. So maybe these are in inches. So maybe it's 6 inches and then 2 inches. So when I add these up, I would get 16 inches altogether. So that's what your perimeter is. Okay. So let's try another example. And I'm going to give you a different shape that doesn't necessarily have a name here, but maybe I kind of have this, I don't know, this kind of funky shape here. I guess it does. I guess it is a sort of hexagon, right? It does have 6 sides in this case, although they're not all equal necessarily. So I know it's not to scale, but kind of bear with me. Maybe this side is 2 centimeters. This one is 3 centimeters. This is 1 centimeter. Here we have 2 centimeters, maybe 2 centimeters, and another, we'll say centimeters. And again, I know it's not to scale, so just kind of bear with me here. So if I want to find the perimeter of this object, this is going to be a hexagon because I have 1, 2, 3, 4, 5, 6 sides. I'm just going to add them all up. So I'm going to start here. So I have 3 plus 2 plus 3 plus 1 plus 2 plus 2. So I have 1, 2, 3, 4, 5, 6. There are my 6 sides. And I'm going to add these up. So let's see, I have 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 centimeters. All right. Another thing I want to talk about would be some keywords for adding and subtracting. Start a little down here. So think about some keywords for addition you may know. Think about some keywords for subtraction you may know. This could be a good time too to pause the video and see if you can think of some on your own first before we go through the list together. So if you want to do that now's a good time to pause this. Some words obviously that mean addition are of course the words add or added to. Another one we see a lot, particularly when we're little, is the word plus. If you have the word increase or increased by, that often means addition. Something like more or more than often means addition. The word total, we saw, definitely means addition, as well as the word sum also means addition. And again, these are just some S-O-M-E examples, right? So there's many more examples of words that could mean addition. Now I do say could because sometimes when we read through a problem, then maybe it doesn't actually mean addition. We have to be careful. Sometimes words are just words in English, right? We have to be a little bit careful here. Some that are pretty clear are things like sum and total are usually pretty clear, add, added to, and so on. But as you're going through, you do also want to read the question carefully and just make sure there's not something else going on in the background that you may be missing. Now, for subtraction, we do have some key words here. Of course, the word subtract, the word difference, the phrase take away, or minus. We see that a lot as kids. Decreased by, or decrease by. And then some other ones here we do have to be a little bit careful of. So less and less than are both mean subtraction, but we have to be careful of the order. So for instance, if I had an example, let's use a different color here, that said 5 less 3. Well, that means 5 minus 3. So less here just means subtraction. If I say 5 less than 3, or let me do a different example. Let's say I do 7 less than 10. Well, 7 less than means that 7 is the part being subtracted because of that word than. This is actually 10 minus 7. So we need to be a little careful. And the same thing is true with subtract and subtract from. So I'm kind of running out of room here. Let me do an example. Let's say I have 5 subtracted by 3. So that would just be 5 minus 3. But if I have subtract from, that's going to change my order. So for instance, maybe I say 8 subtracted from 10. Well, now I'm looking at 10 minus 8. So I want you to be really careful with subtraction. Remember, subtraction is not commutative, it's not associative. The order is absolutely critical, or you'll get the wrong answer. So when you see keywords like than and from, then what they typically do is you want to watch out. They usually switch the order of how it's given. So 7 less than 10 is actually 10 minus 7. 8 subtracted from 10 is actually 10 minus 8. So those words than and from, really watch out because they do change the order here of your examples. Let's do an example. All right, so this says the following. The radius of Jupiter is 43,441 miles. The radius of Saturn is 7,257 miles, less than the radius of Jupiter. And our question is to find the radius of Saturn. Okay, and as a note here, so this information has come from the National Space Science Data Center. So when you have a word problem, these can be tricky for students. You really want to read through carefully and see if you have any keywords, or sometimes there are not keywords, but there's an overall idea here, right? So if I read through this problem, it says the radius of Jupiter is 43,411 miles. The radius of Saturn is 7,257 miles, less than the radius of Jupiter. So remember, less means subtraction, and that word than is, we have to be careful because the order is going to change, right? So it's not going to be Saturn minus Jupiter, it'll be Jupiter minus Saturn. So the radius of Saturn is another word for equals 7,257 miles less than the radius of Jupiter. So I'm just rewriting the key piece in words here. And again, when I see less than, I'm going to think of subtraction, but I'm also going to think of the order changing as well. So my value for Jupiter was 43,401, and then my value for Saturn is 7,207, or the value I'm subtracting for Saturn, excuse me. So now I can go ahead and do my answer. I'm lining everything up, and then I'm going to go ahead and start subtracting from right to left. Now I can't do 1 minus 7, I do have to borrow here. I make the 4 a 3, and the 1 becomes an 11. So 11 minus 7 is going to be 4. Now I cannot do 3 minus 5, so again I have to borrow. That 3 is going to be 13. 13 minus 5 is going to be 8. 3 minus 2 I can do, that's 1. Again, I cannot do 3 minus 7, so I'm going to borrow and try to see how to make this a 13. 13 minus 7 is 6. And then here you could put a 0 if you would like, and I just have a 3. So the radius of Saturn is 36,184. And think about your units. Our units up here were miles. Okay, everybody, so the last example I want to do here for an application, and again, there's tons of applications, I'm just going to touch on a couple, would be looking at graphs too. So here I just pulled up a bar graph example online from Wiki Educator, and normally Wikipedia pages are not sources that I highly recommend, obviously, but I really just needed a quick graph to show you guys, so this was one that was already listed. And this one is an example of birthday of students by month. And again, I'm not going to assume that this is actual real data. This is likely just an example that someone created. So just keep that in mind, but we can still look at it. So a couple things I want to point out with bar graphs is that the height of your bar for each, in this case, month, is given by the frequency of the data. So if I look at May here, I can see that May bar graph goes to this line right here. And if I scroll over, I see it matches with the number 8. So what that means is that 8 students had May birthdays. If I look at June and I look at the height of that bar, and again, I see the height matches over with the number 10, and that means that 10 students had June birthdays. So I could ask questions like, how many more students had June birthdays than May birthdays, for instance? So I could see that 2 more students had June birthdays than May birthdays, right? Or maybe I could compare October to November. So I see that I had 8 October birthdays and only 4 November birthdays. So I could say, well, what is the difference between October and November birthdays? 8 minus 4 is 4, so I can answer that question there. So one thing you want to be careful about with just any sort of word problems, again, obviously is the wording, but here's an example, and I mentioned this already when I was talking to you. But let's just talk about a little bit clearer. So the question I asked a few seconds ago was, how many more June birthdays are there compared to May birthdays? And I'm just writing this down so I can share my other page with you. We're using the bar graph, but we already said that June birthdays, we saw there were 10. And for May birthdays, we saw they were 8. And we were able to figure this out by looking at the height of those bars. So remember, the height of your bars here are going to give you the frequency. Now, your bar graphs can always go horizontal. So in that case, I guess it would be the length of your bar would give you your frequency. But here we have a vertical bar graph. So I'm going to go back to my other paper real quick. All right, so here's that question that I wrote down. And you really want to be careful here. So if you go through and you read the question, you do see that word or. And I know we said already, well, that more usually means addition, right? If something is more than something else, we're adding. But this one's a little trickier because the question is not really just or. It's how many more. When you have a question that is how many more or how much more, then those are actually comparison questions, right? So in a case like this, it actually is subtraction. So a key idea, although not a key word, but a key idea for subtraction is comparison. So if you have a question like how many more, how much more, then you're actually going to subtract. Okay, so there are 2 more June birthdays, right, compared to May birthdays in this case. And that is a different question than something like, let's say Joe has $5 and Sue has $2 more than Joe. How much does Sue have? So here we have that keyword of more, right? More than, and it really does mean addition here. So it's a different kind of comparison. I'm not looking at the change between two. So here, this comparison is really about the change between the 2 months. Here I'm saying that Joe has $5 and Sue has $2 more. So Sue has $5 plus 2 is $7. And this is where the wording gets really tricky. So you want to read through carefully. You do want to always look for keywords. Keywords like more, they're important, but you have to look at the overall context of the problem as well to make sure there's nothing else going on. Here we have a more straightforward more question, right? Where the more really does mean addition, which is what we expect. Here, we're asking you to actually compare the change between 2 months. And we're comparing change, that is a subtraction problem. So again, read through carefully, watch for those keywords, but also think about overall, like what is the question asking and how can we best answer it?